Hello guys, I'm back. Today I will talk to you about what are the main points that you should observe when you are doing your pipe instrumentation diagram or reviewing a pipe instrumentation diagram from a supplier. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to get hundreds of contents related to chemical process engineering and plant design. One of the activities of a chemical process engineer that works with plant design is to develop the piping and instrumentation diagram. This is a diagram used for a multidisciplinary team to develop documentation for the erection of an industrial process or industrial plant. And as a chemical process engineer, you are responsible for selecting the major components of a process like equipment, controls, instrumentation, process safety devices, and etc. And all of these items are shown in the piping and instrumentation diagram. So the first thing that you should consider when adding or when doing a pipe instrumentation diagram is to add what is really necessary to do the monitoring and control of your process. For instance, if you have a distillation column or observer column where you have the water going from the top and gas going to the bottom, and in this process you are removing CO2 from your stream. At the first site, the chemical process engineer will want to add all kinds of monitoring to have the information in the control room or in the SCADA. For instance, we'll add the flow meter, a pressure transmitter, a temperature transmitter. So this is what as chemical process engineer we want to add to our process, because this way we have all the conditions that we need to the process to verify with the process simulation results. But in real life, we need to observe what is really important for the process. If I need to control the pressure of my column, I need to have a pressure transmitter, for instance. If I need to control the flow in my process, I need to have a flow transmitter. But if the flow is not a variable to be controlled in the process, eventually I will not add that to my equipment. The temperature is the same if I'm not having any kind of heat exchanging where I need to control the temperature of the process. I will not add a pressure transmitter or a pressure indicator for this location. So here today I was revising all the day documentation from a supplier, and I was evaluating what is really necessary for the process. For instance, I have a column and I have two intermediate columns and a stripping column where I do the gas sweetening of a natural gas stream. And in my first column, I have a temperature transmitter. In the stripping column, I have a temperature transmitter. And at the preliminary stages of the process, we add a temperature transmitter for the intermediate columns, each one of them. But as I don't expect to have any kind of heat exchanging between the first column and the last column, there is any reason to keep the temperature transmitters in the intermediate column. And why I am removing them? First, because they are not necessary. If I can save money with instrumentation, is better. And second is that it's not only about the money spent with the instrumentation. Every time that you add an instrument, a control valve, a manual valve to your piping instrumentation diagram, you are giving or you are adding work for other discipline. So to have the temperature transmitter working in the field, I have the interface with the instrumentation engineer, with the automation engineer. I will have interface eventually with the electrical engineer. So if I remove a piece of instrumentation from my pipe instrumentation diagram, I am saving much more time and money than just the price of the instrumentation. So take a look or be aware about that. Add to your pipe instrumentation diagram only the monitoring and controls that are really needed for your process. Another thing that you must observe, and I was able to do that because I am revising the pipe instrumentation diagram with the plot plan of the process, is where the component is being installed in your process. I have here columns with 15, 17, 8 of elevation, and if I add isolation valve in the top of the distillation column or in the top of the vessel, that will not be easy for handle. For any reason, if I need to do the maintenance of this column, I will need to have special devices. I will need to have special features to reach 17 elevation from the bottom. So what I take a look here, for instance, I have a PSV at the top of my vessel, and the vessel has 17 meters of age. So instead of adding the PSV at the top of the vessel, I have a withdrawal line or a gas line at the outlet of this vessel that goes to a pipe rack that is around 2.5 to 3 meters above the ground. So this way I asked for the relocation of the PSV from the top of the vessel to the pipe header, where it's much easier for the maintenance of the pressure relief device. The same with some isolation valves that I verified in this layout. Some of the isolation valves was at the nozzle of the equipment that is 15 meters above the ground. So I asked to bring them to the elevation for the normal operating conditions for the operators, because I don't have a necessity. It's not a need, or it's not mandatory to have the isolation valve at the nozzle of the equipment in the case that I am verifying. So this is at least two things that you must be aware when you are doing, or you are developing or revising or verifying a pipe instrumentation diagram. Another thing, and the last thing that I will share with you, is about process safety. You must be alert about what are the kinds of hazards or the occupational hazards that can happen when you are dealing with your pipe instrumentation diagram. For instance, here again, I have a pipeline and it goes from the bottom to 17 meters above the ground, and I will have a column of water, and at the bottom I have some instrumentation and control valves. So to remove these control valves, the operator will untighten the bolts and will remove the instrumentation, or will remove the control valve. But to do that safely, I asked to add a drain valve at the bottom of the pipeline, because this way I am able to drain the column of water that I will have in my process when I stop the plant. Instead of untightening the bolts and letting the liquid that is inside the pipeline go to the floor, it's much cleaner and much more safer. It's safer if I add isolation, a drain valve, and it can be a small valve compared to the pipe that I am working with. If I have, for instance, 8-inch pipe and I will add a drain valve, I will not add 8-inch drain valve. I will add 1-inch valve, for instance, 2-inch valves, for instance, and that way the operator can plug a hose, and with that lead or route the drain of this column of water to a safe location. So with this, we have seen the three main points that you must be alert when you are developing your pipe instrumentation diagram. The first one is add only the components necessary to the monitoring and control of your process. Second thing, if possible, verify where is the location or add to the pipe instrumentation diagram notes related to the location of the components that you are dealing with your process. And third one and last one is to look for the process safety and occupational safety of the operators in order that you don't hurt and you don't have any kind of accident or incident in your plant design. So guys, that's it. If you want to know more about chemical process engineering in plant design, take a look in the next video that will appear to you right now.